a short lesson about the sum to infinity of a geometric series. So suppose we have a geometric series like this, where the first term is 1, and then a half, and then a quarter, an eighth, and so on. So clearly the common ratio is a half. We're multiplying by a half between each term. And you can see that what's happening is the terms are getting smaller and smaller and smaller. So they are becoming less and less and less significant. Now if I think about what's happening as I add up, so if I just added the first one term, if I just kept it as one term, I'd have an answer of 1. If I added the first two terms together, 1.5. First three terms together, 1 3/4. First four terms together, 1 7/8. This total is going up by a smaller amount each time. So every time I add on an extra term, it's becoming less and less significant to the total. So what's happening is the total, or in other words, the sum of this series, is tending towards a finite limit, a fixed limit. And in this case, that fixed limit is 2. The formula, which we'll see in a minute, is that the sum to infinity of a series is the first term divided by 1 minus the common ratio. So in this case, that's 1, the first term, divided by 1 minus a half, the common ratio. 1 minus a half is a half, 1 divided by half is 2. So even if I added up a million, trillion, quintillion terms of this sequence, it would just get closer and closer to 2, but never quite equal it. So it's tending towards a limit of 2. Certain things have to be true for this to occur. And for this to occur, what has to be true is that each term in this series has to get smaller and smaller and smaller. Otherwise, when we added them on, they wouldn't be of reducing significance. So if the terms in the series have to get smaller and smaller and smaller until they become insignificant, that means that the common ratio must be a fraction. It's allowed to be between 1 and -1, so it's allowed to be a negative fraction, but it must be a fraction that's less than 1 and bigger than -1. So in other words, the magnitude of the common ratio must be less than 1. If that's the case, when we apply the normal formula for the sum of a geometric series, which is this formula here, then because the magnitude of r is less than 1, that means r times by itself a huge number of times will become virtually 0. So even if r was really close to 1, if r was 0.99, if I did 0.99 times 0.99 times 0.99 times 0.99 an infinite number of times, eventually that result is getting smaller and smaller and smaller and tending towards 0. So because this term in the formula tends towards 0, all we're left with on the top is u1 times 1, so u1, and on the bottom 1 minus r. So that's where this formula comes from. So in summary, the formula for the sum to infinity of a geometric series is u1 over 1 minus r, and this only occurs when r is between +1 and -1, not inclusive. The second addition to geometric series here is using sigma notation. Sigma just means add up. So what this means here really is put r is 1 into this formula, and then add it to the calculation that I get with R is 2, R is 3, R is 4, and stop with my last one being R is 5. So in other words, if I put R is 1 into this formula, I would get 2 times 1 minus 1, which is 1. If I put R is 2 into it, 2 times 2 minus 1, 3. R is 3 into it, 2 times 3 minus 1, and so on. So the easiest thing to do when you're dealing with these questions is actually to write out the first few terms of the sum, write out what the sigma notation is telling you to do. Once we've done that, I can see that this is a sequence going 1, 3, 5, 7, 9. So in other words, I can see it's an arithmetic sequence. First term 1, common difference 2. So once I've spotted that, I can put it into the normal arithmetic sequence formulae. Or if it's a geometric sequence, I can put it into the normal geometric sequence formulae.